All right, everyone. I think that it's 10:34 my time, so I think it's time to get started. And there's quite a lot of exciting content to get through today. So thank you all very much for joining us and taking the time out of your day. I think that, between lockdown level 3, COVID, and the cyclone, 2021 is turning out to be an interesting start. But I think that what we're going to present to you today will show you a bunch of ways that should make your lives a lot easier. From an agenda perspective, I'm just going to do the welcome and introduction. In terms of the types of things that we're going to be going through today, I'll do the welcome and the intro. I'll do the summary from a Cloud Connect part 1 and 2, and then I'm going to be handing over to Emmanuel. Emmanuel is from Autodesk, and he is joining us from the African continent in general. If I'm not mistaken, Emmanuel, I think, is in Kenya. Then I'm going to hand over to Nuran and Anin, two of our specialists from Baker Baines. They are going to take us through Generative Design 101. And then we're going to move over to Shuaib, who's going to take us to Scan to BIM 101. I have been asked to put the camera on, so I hope that you can all see me in my freshly showered and clean glory, and then I'm going to be handling the questions and answers and the close. So throughout the course of the presentation today, please feel free to post any questions in the chat box. The staff are ready to answer any of your questions, but ideally post the question and then we'll handle them all at the end. So with that said, let's get into action. Many of you might have heard about who Baker Baines is, but I think I always enjoy taking the opportunity to remind people who we are and what we do. We are going to be 6 years old in about 2 months' time, and we have grown enormously over the last 6 years. Primarily, though, although we started as a design software consultancy, generally now we like to focus on business process improvement, and there we are supported by being an Autodesk Service Provider Select partner, one of very few in the country, as well as being available on the services marketplace. I feel we have a very unique consulting methodology, which helps our customers go through the process of transformation in a stable and controlled way, and that generally produces good returns. So primarily business process improvement consulting. Then we're also able to do the survey and design part of things, which you're going to see a little bit more about today from a Shuaib perspective. It's some really exciting technology. We call it Scan to BIM. It's a workflow that is designed to help you really, take reality capture and bring it into your modeling. And we're supported by the Topcon and the Leica brands there. Then traditionally on the Autodesk side of things, we're the second largest Autodesk partner in South Africa. We manage many licenses with some very big and important customers, but at the same time, some very small organizations who are just as important to us. And then lastly, we're a blended learning provider. And this, for me personally, is one of my most exciting pieces, because we were the first partner to introduce an online e-learning portal, which is the CAD Learning Portal. It is Autodesk. It's Africa's only Autodesk approved content publisher. And we're very excited about CAD learning and what it can do for your teams, because, although primarily people look at us and they think, oh, yeah, you can sell us some Autodesk software, there's a lot more to us than just that. From a Cloud Connect event series, we all had to change the way that we did things in the course of last year. We started to introduce some of these Cloud Connect events. We hosted the first one last year during the time when Autodesk were promoting BIM 360, specifically BIM 360 Docs and BIM 360 Design. And that was a really exciting event where we were able to bring together some of our customers whose faces you can see there, as well as Yanni, our Director of Professional Services, to really talk about their experiences of BIM 360 Docs and BIM 360 Design and what it felt like working remotely, working from home, but still having to deliver these large and complex projects. This was a particularly well-received event, and all of the people on there continue to be fantastic customers of ours. If you're interested in seeing more about this event, you can go back and have a look at the archives on our website. But specifically, this is where our Cloud Connect events series started. Then we moved into Cloud Connect Part 2, which focused more on a common data environment, but more specifically in accordance with the ISO 19650 guidelines. Now, this is something that is challenging a lot of our customers at the moment, but we all need to know how to respond to the ISO requirements, and we were very lucky to have Marek from Autodesk present this particular topic. It challenged a lot of how we do things from an ISO perspective, and more what we're learning is a common data environment. A common data environment in a single organization is complex enough. To now try and look at a common data environment amongst a whole design professional team is even more complicated. However, the benefits are real and tangible. So that was the second part of our Cloud Connect event. Today's Cloud Connect event is to specifically look at 3 ways that technology can improve your projects in 2021. If your 2021 has started out anyway the same way that ours has, it really started with a bang, in the sense that we've all come to terms with learning to live from a lockdown, different levels, but we've all learned to sort of work from home and still deliver what we need to deliver from a professional perspective. And I feel that the technologies that we're going to present to you today should help improve your project delivery throughout the course of the year. I'm now going to hand over to Emmanuel, who has been with Autodesk he has a long history with Autodesk. If I remember correctly, Emmanuel started working in one of the Autodesk channel partners, and then moved into working for Autodesk directly. I am now going to figure out exactly how to change presenter. I'm not, I just need to figure that piece out quickly. I'm going to switch my camera off. I'm going to go on mute, and then I'm going to hand over to Emmanuel. Would be a lot easier to hand over to Emmanuel if I could find him to hand over.
Yeah.
But there you are. I was looking at the wrong place. I'm sorry, Emmanuel. Okay,
Sorry.
so I'm going to make you the presenter, and nice to chat to you again. Thank you for taking the time to join us today, and over to you.
All right, just confirm if you can be able to see my screen. Can you be able to see which screen? Screen 1
we
or
can
2?
Just need to swap your presenter view.
Okay, swap. Cool. All right. Okay. Thanks a lot for joining us today. My name is Emmanuel, Technical Sales Specialist at Autodesk, and I'm here to actually talk to you about the BIM 360 and an overview of what we refer to as the Autodesk Construction Cloud. During the course of my presentation, we may make statements regarding future events or statements regarding planned or future developments for existing or new products. We wish to caution you that such statements reflect our current expectations, estimates, and assumptions based on factors currently known to us, and that actual events could differ materially. And these statements are not intended to be a promise of future delivery of products. So purchasing decisions should not be made based upon reliance on these statements. So we do not assume any obligations. So typically, this is just a presentation to just show you our reflections regarding future products. So we are hearing all these same things today: the demands on construction, and these demands are higher than before. Like you've heard all these things such as 200,000 people per day being added to the urban areas. 50% of our contractors concerned about finding experienced craft people, and 65% of our construction demand is shifting to emerging countries. A whole lot of pressure on industrialized construction, and the nature of our projects also becoming increasingly complex. So how do we turn this change to your advantage, and how can we partner together to meet this world's needs while ensuring that your business success is also our success? So at Autodesk, we've been focused on helping you thrive through areas of change since our inception, and we led this change through innovative CAD software, evolving the industry through the introduction of BIM, and we are constantly making investments in the world of construction. So we actually identified 3 critical stages of technology that get you to a place where you can start to see these productivity gains. For example, digitization, imagining the construction business of the digital age with a paperless kind of a construction site, and an integration of all these different technologies from design to office to the field. And also the third process also coming up with optimizing all these different aspects of the construction. And so to actually help contractors, we've invested quite a huge amount of resources to bring this unparalleled efficiency gains to the entire construction life cycle, from design to planning. And bringing design data through BIM have been in our DNA since, and we are uniquely positioned to extend the value of that data throughout the plan, building and construction and also operations phase of a construction project, which is why we came up with the Autodesk Construction Cloud. So you might be thinking about, what is the Autodesk Construction Cloud? Typically, it's really comprised of 3 core pillars: advanced technology, the builders network, and also provide a platform that really provides us the predictive insights. Our advanced technology equipping contractors with powerful tools to support them in their workflows in construction. And this mix is very critical, because our solutions, to get real adoption in the field, in the office, they must be intuitive. They need to actually make the job really easier. And typically, our investments have brought together the most powerful portfolio of construction management software products in the industry, like Assemble, BIM 360, Building Connected, and PlanGrid. I'm sure that a wide area of a wide audience have had maybe about Assemble and PlanGrid and Building Connected, but typically these are all products that are part of the Autodesk portfolio, and we decided that to bring all this together, bringing all these powerful tools in one single platform that really enhances how we extend design all the way to building and operations. So all this comes together. All these things come together in one Autodesk Construction Cloud, by offering you the best-in-class technology to support workflows, data shared across different phases, providing you with analytics of data that is critical for you to identify issues in the design all the way to construction and operations. That would be very, very critical for you to operate your building and infrastructure projects. And also, part of all this is also built upon builders network, providing you that network that you really require to connect yourselves with other stakeholders in other projects, that those providing you tools so that you can be able to basically being able to place do things such as bid and tender management and bid qualification. And hopefully this gives you a better understanding of the Autodesk Construction Cloud and how we actually partner to make this connected construction a reality for you. So we believe at Autodesk we believe there are 4 factors that actually enable us to deliver the promise of connected construction better than anyone else. We have been a leader of design in BIM and supported by very well able partners such as Baker Baines to actually take this technology and make this technology available to our customers to also use and also adopt. We have a breadth of portfolio of products products that are running all the way from concept design, detailed design, planning and analysis to building, construction, as well as operations. We have a global presence and support from good partners such as Baker Baines, and also we also actually bring this accelerate the convergence of manufacturing and construction, which is very, very critical in our world today. So I'm just going to run you through maybe a couple of things to just understand, some of these products, assemble the tool that really helps quantity estimators perform both 2D and 3D model takeoffs. A building connected, it's basically a network that connects companies and projects to a network of thousands of companies, construction professionals, where you can be able to do things such as submit bids, invite people to actually bid on these projects, and then through the same platform being able to have people who can be able to actually respond to those bids, and then for the general contractors and subcontractors to take the appropriate action. We also, part of the Autodesk Construction Cloud, we have Plan Grid, which is part of the construction cloud, mostly being used in the Americas and also the EMEA countries. But this pretty much is a mobile first, field first software, and this really helps us to streamline critical workflows, improving efficiency, enable the teams to take on a lot of work and get more work done every day. Finally, this is something that we all know about, which is BIM 360. And we continued and still continue heavily in our next generation BIM 360 solution, moving towards a unified platform, specifically related to project management and predictive analytics. So I know that this, for those of you who might want to understand what BIM 360 is, it's really the integration step in our construction technology journey, built upon Autodesk Forge, which is our web API that is actually based on BIM 3, based on Forge, gathering all the project data from all the design applications, whether it's 2D and 3D, and on top of that, providing you the analytics and insight for you to do design, pre-construction, supporting field execution, going all the way to handover and operations. And I know that quite a number of supported workflows on BIM 360 is document management, design collaboration. If you want to do clash detection and coordination, we have BIM 360 Coordinate. With BIM 360 Build, you can be able to, you have RFIs workflows to being able to also do submittals and transmittals. Also going into constructability and asset management, we have BIM 360 Cost for cost management, a platform also where contractors and engineers can also be able to actually work together and do meeting minutes, many other things on top of data and analytics, but also the same BIM 360 platform that allows you to do quality and safety management. But the other thing that I also want to talk to you about is how do our users and how do industry players really go about the data transfer processes. just like many other in a typical project, you find that data is actually placed in the middle, where we have quite a lot of things that we need to do on a typical project. Think about your work planning, thinking about measurements. There are people who need to do work preparation plans, need to do supplementary documents, and also defect management. But then now in this ideal data environment, we have so many different players, like the architects, the client, the quantity surveyor, the contractor, and the subcontractor. Being able all of these different people have their own different sets of communication platforms. So as it were, everyone gets to integrate into this common project data environment in their own different way. So what happens is that sometimes there are people who use phones, there are people who use emails, there are people who prefer to use maybe other cloud solution services. People like the subcontractor want to report on issues by taking pictures, attaching them on emails. That results to a very manual data storage, where you have thousands and thousands of files, most of which have you have a high tendency of actually losing all this data if you actually go the paper-based way. And at the same time, you actually see this kind of this is something that you always see in a typical construction and also a design office, an office full of paper. And if we decide to go the digital way, we went into emails, but then we agree that sometimes it's very difficult to actually being able to track every single piece of information that comes onto email. In short, we have so many different disparate ways of gathering information, and this results in this kind of a setup. So ideally, when you start talking about integrating systems and basically how do we bring all these things together, you find that people will say that, yes, I work with Excel, I like using Excel. People like to use FTP servers. My plans are on SharePoint and I copying them to BIM 360 manually. Other people want to ask ask us, how do I get all of these photos from the construction site to Google Drive? Is there a common way of integrating all these pieces of information together? So which brings us to the next scenario, whereby we still use phones, cameras, use Excel spreadsheets and work schedules on Gantt chart, maybe on smart sheets. But if we actually talk about the construction cloud, and more specifically the Construction Cloud Connect, which is something that I'm going to talk to you about in the next slide, find that all this data is actually integrated together, having all your data, all your tasks, and all the custom workflows that you want to implement in a project. And that still integrates very many different common data platforms. Could be SharePoint, it could be FTP site, it could be Smartsheet, or could be Dropbox. And still working on the same project, different architects, different a contractor working with an architect who's on SharePoint or an engineer who's on SharePoint, but still being able to integrate all these things together. So which is why I want to introduce the Autodesk Construction Cloud Connect, otherwise known as the ACC Connect. So the ACC Connect provides that out-of-the-box platform. So you can create integrations via your web browser based off on the Workato platform without needing to know how to code. And you can create custom workflows between systems, routing files and data per your processes, and even leveraging the triggers between these systems and keeping these different applications up to date. So whether you want to integrate BIM 360 to your SharePoint or maybe an ERP platform such as QuickBooks, Autodesk Construction Cloud Connect actually enables you to do this kind of a workflow. So how does it work? we have very many different customers and users who actually tell us that I need to find a way where I can be able to integrate my BIM 360 data to my Dropbox or my SharePoint or my FTP site, FTP platform that I'm using. So ideally, the Autodesk Construction Cloud Connect allows you to integrate and create recipes between BIM 360 and your cloud or your SharePoint kind of a platform. And with the same kind of a workflow, this enables you to even export your BIM 360 documents, whether they are plans or documents, out to your Dropbox or your SharePoint or whichever other cloud platform that you are actually using. So this ACC Connect it's connected to project management tools, such as it's also easily integrated with Excel or Smartsheet, depending on the kind of project management tool that you are using. The ACC Connect is also provides you that kind of a platform that allows you to do this kind of work. So to help you through these stages, and which is why the ACC, the Autodesk Construction Cloud, provides you that platform that allows you to complete set of tools that allow you to design, plan, build, and even operate your buildings and infrastructure. So this is just an example of a demo of a file that has been a workflow or a recipe that is within the Autodesk Construction Cloud Connect. And this is just a typical workflow where this user actually creates a recipe that instructs the platform from BIM 360. Once a document has been approved, it can now be shared onto a platform such as SharePoint, which maybe the office, the design engineer is the one who's actually using it. And because, like I said, this is something that is easy, I would actually say that this is a plug and play. This is just a platform that really, just a video that actually shows you exactly how that works. So from BIM 360, once the document has been approved, you go all the way to SharePoint. And once, this is just an example of this kind of a platform that actually allows you to actually have that plug and play kind of a workflow, enabling you to connect these two different platforms from the same common data environment. As I go to my as I think about the construction cloud, for most of you might have heard about the announcements that we did at AU last year. We also launched the next generation, the unified platform, the next generation of Autodesk Construction Cloud solutions. That includes the Autodesk BIM Collaborate, that allows you as a project team member to align and execute on design intent by managing everything from design collaboration and even coordination. Going into, we also launched the Autodesk Takeoff, which empowers estimators to automate 2D and 3D quantification from a single comprehensive platform. And also, we also launched the Autodesk Build. So this takes a more in-depth look at how we normally go through the project management aspects of our construction project, because it really delivers that connected set of field execution and project management tools for builders in that single platform that is very easy to deploy, very easy to adopt and even use. And you can even see that we also have much more capabilities onto the Autodesk Build platform, such as better project management, cost management, all of which are part of all this offering will be Autodesk Docs, which will be part of the new AEC collection, which would be coming soon. So the Autodesk docs will be part of the AEC collection that really empowers project members to also be able to collaborate on that single common data environment and sharing all this very critical design information with the rest of the teams. So what does this actually mean for you? These products support teams, whether they are in the office or whether they're in the job site. They bring your data together to perform that connected workflows for projects, and they deliver very powerful insights to highlight and mitigate some of these risks that come across projects and also businesses. And for your teams, this also enables you to also have that predictive outcome. So the Autodesk Construction Cloud provides every team member with specific tools that you need to do your job, to collaborate with others, and also to digitize your task and captures the data in one central place. And for you, people in the field, projects that the Autodesk Construction Cloud leverages that data that is collected by your teams to drive that efficiency and connect workflows from design through to handover, while delivering a real-time view of project progress. And also for the business leaders, the Autodesk Construction Cloud helps you to understand the health of your project portfolios with very up-to-date reporting, providing you that insight, providing you these analytics that ultimately contribute to your organization improvement and even driving innovation. Over to you.
Thank you very much, Emmanuel. I think that everyone can agree with me when they say that the way in which buildings are built hasn't changed in a very, very long time. And I think that it's really exciting to start to see what Autodesk are rolling out from a future perspective. While I'm busy changing presenters, I actually just wanted to say it's so nice to see some familiar names on the attendee list. You know who you are, so nice to see you here. I'm now going to introduce Nuran and Anin. Now, and Nuran, I know that you're sharing and you're presenting now. Won't you just go to the next screen for me, please? Or whichever of the two of you are driving it. Thank you so much. I take great pride in building a diverse organization that is reflective of the country. And having these two ladies present today is something that is just very close to my heart. Firstly, from an Anin perspective, Anin joined the company right about the middle of last year from an architectural not client, but an architectural field. Anin is based in Gauteng. She's the BIM specialist from an AE perspective, but also she has her master's in architecture. Some interesting things about Anin, maybe you're not aware of this, but she's a professional stylist, and you can tell about how nicely her hair looks and how pretty she is, that she just naturally knows how to make everything look fabulous. She worked in the Cayman Islands as an au pair, and she enjoys running when I'm not nagging her about some other things. And then from a Nuran perspective, Nuran is seriously such a powerhouse when it comes to understanding BIM from a large organizational perspective. I think Nuran is not only one of the most highly qualified people in our organization, but also one of the most highly qualified people in the Autodesk channel. She has a master's in structural engineering, and some other interesting things that you might not know about Nuran. She is a maths and physics tutor, so yes, she is a person who actually enjoys maths and physics. She also enjoys running and swimming. And then another little treat there that you might not know is she's an avid cook/baker, and she's got a pretty interesting Instagram account that showcases some really nice sweet treats. So, you know, when you're tired of losing weight, you can look to her Instagram to get some inspiration. So the ladies of BIM, I hand over to you to take us through generative design.
Thank you, Richard. And thanks for giving a bit of our secrets out there. Richard also is very good at making fudge and things, so I'm not the only one that's busy in the kitchen. But besides cooking and running and swimming, we are here to talk to you about generative design today. So I will just run straight into the agenda. So we will talk about why would we want to consider generative design? What are the problems that we are trying to solve? We'll also give a quick overview of what it is, what is generative design, and then compare the traditional design processes with this generative design process. We'll also look at some of the benefits of generative design and how to get started, what tools are available for you to get started. We'll look at some practical examples and how to use the software, and then we will conclude and just run over some takeaways. So jumping straight into the problem statement, why are we talking about generative design today? So climate change is a reality. You might not have thought that this presentation would start off with talking about climate change, but it is something that I'm sure you are aware of. We also know that our natural resources are diminishing, and the built environment really plays a big role in this. Studies show that 40% of global energy is used by our built environment. 25% of our water is consumed by the construction of buildings alone. And building construction contributes to about 30% of global waste. So unfortunately, or maybe fortunately, architects and engineers as designers of the built environment have the responsibility really to respond to these kinds of issues. And generative design workflows have the potential to revolutionize the way that we design by using goals and measurable outcomes that ultimately would guide our designs towards a more sustainable and responsible design. And also generative design is not new. It has been adopted and practiced by other industries for many years, specifically industries like manufacturing, aerospace, and even sport. We'll get to what generative design is and how to use it in a bit. But the building and construction industry still uses very traditional methods of design. But this is slowly changing as we are learning the benefits of generative design from the aforementioned industries. One of the benefits being the opportunity to minimize waste. The overuse of materials in the construction industry is very common. So for example, a concrete beam typically would look like this. But the material that you actually need to fulfill its structural requirements is more something like this. So the beam might look a bit weird, but it is optimized and it's just what you need for it to perform to its minimum requirements. And this being optimized, but optimized can also mean different things depending on the requirements of what you want and also who you ask. But ultimately, generative design can help us to reach these kinds of solutions that wouldn't necessarily be considered when we use our traditional design processes. Optimizing the shape and form of the elements that we design directly reduces the amount of material that we use, and as such, reduces the amount of waste that is generated in the construction industry. So that's why we would actually want to consider this and employ it. If you look at this figure, it shows that the contribution of global carbon emissions by various sectors in 2020. The numbers are from the Global Alliance for Buildings and Construction's annual status report. And as you can see, the building industry is the leader of carbon emissions with a contribution of about 38% compared to transport and other industries. And this 38% includes carbon emissions generated during the production of the construction materials, as well as the actual construction activities themselves. So there's a big opportunity for us to reduce the amount of building material that we use, such as concrete or glass or steel. And concrete is perhaps the biggest culprit because cement production is highly intensive, but that is a topic for another day. Today we're talking about generative design. So what is it? What it is not is that it is not just a piece of software, but rather it's a design approach. It doesn't take away anything from the problem-solving process that we are used to. It is more a process whereby designers use automation with a goal-driven approach to design. The calculations and considerations made by designers are often very straightforward, but having to repeat them dozens of times a day is time-consuming and can sometimes be frustrating. And also, as designers, we are often limited to the amount of solution options that we can produce. And in most cases, the option that we do select to move forward with is not necessarily the best solution. So making use of this design process gives designers a better insight for faster and more informed decisions. And as the designer, you would define specific design parameters to generate many potential solutions. So basically, you're telling the software what results you want, and it gives you hundreds and thousands of options along with data to suggest which design performs the best. So generative design also is not here to replace humans. I think sometimes that's a common misconception. And that's because we are crucial in the design process, because we are the ones who define realistic parameters, and we consider things like cost and constructability in addition to any other design parameters as well. And all of those things together influence what the optimal design would be. So if we look at the history of how we design and the tools that we use, you'll see this is the timeline of the evolution of the Autodesk tools and the impact on the way that we design, or maybe vice versa. But traditionally, we rely heavily on CAD, which is like computer-aided design or drafting. And drawings are not on this timeline, as you'll see, but essentially both the good old drawing board and the CAD tools are used for the purpose of documenting a design decision and then relaying the construction intent. And then sometime after Revit came into the picture, and it allowed us to make use of parametric modeling and parametric design, where the model elements are revised instantly, and this also instantly informs our design decisions as well. And then shortly after, design automation became possible with computational modeling with tools such as Dynamo and Refinery, and they really are lots more. But this type of automation makes routine tasks much faster, and it, like I mentioned before, it provides us with a number of options and solutions that designers can choose from, and it gives us the opportunity to spend more time on other complex design decisions and just make better decisions overall. So what we are going to talk about today are the tools that can help to create these hundreds or thousands of options and then help us to optimize our designs by choosing the best option. So just to compare the traditional design process versus the generative design process, you'll see this is probably very familiar, and most problem-solving approaches would follow this kind of cycle. It starts with identifying the problem. So you see that there's a problem or there's a need that needs to be fulfilled. You would then define the conditions and the constraints that the solution needs to be in. And then you would come up with ideas and different types of solutions that would solve this problem within its constraints. So traditionally, we would do this by hand, as we would say, maybe use Excel or other industry programs that produce like one result at a time with a set of inputs. And perhaps you would come up with 2 or 3 solutions in a reasonable amount of time. And then often this could be an iterative process. Maybe the solution you find does not work. You have to go back, tweak some things, do some trial and error until you get to a workable solution. And then maybe you have 2 or 3 workable solutions, and then you would choose the best one based on the criteria that had been set previously. And then this solution will then be documented and sent to site for fabrication, where it will be built. And then, of course, it is always good practice to evaluate your solutions and the execution of the solution to inform you the next problem that you solve following the same cycle. So this design process will lead to a solution that meets the minimum requirements for sure, but it is not necessarily the best of the few options that we had. So we want to try and get towards the best solution. And that's what we try to achieve with the generative design process. And you'll see that the problem-solving process is very much the same as the traditional process, except that so you'll start with identifying the problem, you'll define the conditions and the constraints, and then come up with ideas. But these ideas now, however, are being generated with the help of a computer or a generative design software that can produce hundreds of thousands of possible solutions, depending what you ask for. And then once again, the designer will choose the best solution based on the criteria previously set, build the solution, and then again, evaluate the execution of the solution. So really much the same, you just have more options to choose from, and perhaps there will be a solution that you would not necessarily have thought of had you done it the traditional way. So what happens inside this computer or the generative design software? So this is things that are happening behind the scenes, basically. But as the designer, you would define the model, you define the problem that you are working with, and this data is generated into a computational strategy that is evaluated by the software. And this loop is what is happening inside the software. So if you have multiple objectives, multiple goals that you would like to be met, you can also then score these objectives and view it in a type of report, and you can see how well each of the individual objectives can be met, and then choose which one you are most satisfied with. So much the same like when you're choosing a car on Gran Turismo or Need for Speed or something, and there's different scores for like speed, acceleration, or turning ability, or whatever the case. You can view the scorecard and then choose the best car based on what you want. And then back to now the model. If you're happy with the results that you have been given, if you're not happy, you can then refine the process until you are happy, and you can make an informed decision based on the feedback that you are getting. Okay. And then just in summary, comparing the two again, with the traditional design process, typically we would decide on what the geometry of the building and its elements are, for example, and then analyze it with the various types of loads, and then we obtain a set of results. With the generative design process, we basically are defining the results that we want to see, and together with the parameters that define the problem, the software will tell us what the geometry should be and how the elements should look for a more optimal design. So essentially what we are doing is we are generating a design that meets our requirements. So now I'll hand over to Anin, and she will tell you a bit about the benefits and some more things about the tools.
Thanks, Naron. So if we look at why do we want to use this tool, Naron, I just want to check, can you help me with the slide to just change it?
Okay, I've given you control, Anin. Can you see if you can go ahead?
Let me test it again.
There we go.
Okay, cool. Okay, so first of all, it allows you to generate options using the power of computation. So in other words, like we said, you use artificial intelligence to automate repetitive design workflows, and you can also then generate way more design solutions than with the traditional way. Also, it allows you to explore the full range of options while focusing on high-performing solutions. So what it means is that you waste less time on basic space planning exercises, and you've got more time available for serious design development and also solving problems. Then also you can gain more insight into your designs by studying the relationships between the inputs and the results at scale. In other words, having better data allows for better and more accurate design solutions. And then also, it enables you to make informed decisions in less time by leveraging what is learned in each study. So with a smaller input, you can generate a larger, a more accurate outcome. And you can also do this at a much quicker pace. So if we take it back to 2021, having an improved and more intelligent workflow and also solutions is crucial, not only to future-proof your business and build resilience, but also, like we said, is to create sustainable and responsible designs. Okay, so if we then look at how we get started, what tools do we have available to do this? Now we know that Autodesk has various products available, which allows us to create better designs. But today, as we're talking about generative design, we're going to specifically look at Revit and then also at Dynamo. Okay, so looking at Revit, it's a new feature that is now available through the AEC collection with Revit 2021. And within Revit, this generative design tools, it allows design technologists to create scripts and then share them with other Revit designers. So for example, there are some users who don't necessarily want to get into the very details of scripting. They can then use these to leverage these automated workflows in the context of their Revit model. And they can create design studies based on goals, constraints, and inputs to derive a high performance option, which then allows for more informed decision making. Also, just to note is that this generative design tool is automatically installed with Revit, and it's updated via the Autodesk desktop app and also with your Revit updates. If we just look at some of the benefits, once again, it's a huge time saver as you can generate and evaluate designs. Yeah, a lot more options available, and also then it automates repetitive work and creates better designs. Okay, so if we go over to Revit itself, of what it looks like when you want to create a study. So within Revit's Manage tab, you've got two tools available, which are the Create Study and also your Explore Outcomes. Now, these studies are all backed by Dynamo scripts, and if you export them from Dynamo, they will show up in your Revit Create Study dialog, like we can see here. So as we see, there are various study types available. For instance, the first one is your grid object placement, and this you will typically use for things like lighting layouts, sprinklers. You can set out tables in a restaurant, and it also allows you to place Revit elements in a grid. You can also measure how far or how close they are together. Also how well they fit into your space, and you can also use this as a point of departure for further design development according to what you want to do. So other study types are the stepped grid object placement, and then also the randomized object placement, which allows you to speed up the process of entourage. So for example, if you want to lay out people in a plaza, you can use this tool to lay it out with, and you can also use it to see how close together people are and also how many clusters there are. Okay, so if you have chosen your type of study, you will then continue over to your Define Study dialog, and this is where you will then set certain parameters and also define it. Okay, so all of these choices are captured in the backing Dynamo script. So in other words, the design technologist designing this script, he determines how this interface will appear to the person using it in Revit. So what we see here in this dialog was set up in the script in Dynamo. So obviously you can customize it as well. You can do things like provide select notes. For example, if you're busy with a workspace layout, you can select a room, you can select an element that you want to lay out. You can also specify what is going to vary your desk rotation, and you can also set design goals, and then once you've set that up, you can then select to generate design layouts. Also, just to note is that a recent add-on was that you have the ability to save default studies. Okay, so after you have generated a layout, just go to the next slide, then your Explore Outcomes dialog will open. And this is where you can keep track of options, and also it lets you do things like sort them by different parameters that you've identified. And you also can rank and filter your results. So once you've decided on a layout that you like, you can create these elements back in Revit. Okay, so as for who is this tools available? It's available for all collections and then also enterprise customers on, as I said, the Manage tab of Revit 2021. Okay, and then I will give over to Nuran again to just take us through a few practical examples.
Thanks, Anin. Before I get to the practical examples, I will just expand a bit more on Dynamo. Anin showed us some of the out-of-the-box case studies that are available in Revit. And alternative to this, you can also create customized studies. And to do this, you would use Dynamo. Dynamo is now part of the AC collection as well, and it is available with Revit 2021. Previously, it was an add-on, but now it's one-stop shop kind of thing. And what it is it's an easy visual programming environment. And what's nice is that it doesn't require any previous programming experience. So the programming is happening in the background, and as the user, you visually put together a string of actions that you want the Dynamo to execute. There are also many open source scripts that are available online, and there's a number of packages that can be downloaded directly from the Dynamo interface. These packages have been developed and programmed by others, and they are freely available. It is a set of customized actions that help you to automate specific tasks that are in this package. So the generative design package is one of them. So you just download it straight from the interface, and then this is what will allow you to push your scripts from Dynamo into Revit's generative design tool, where you create the case studies. And so in your script or in the script, it will include variables that you want to play around with. So these would be your input nodes. So in the case of the workspace layout that Anin mentioned, perhaps the number of desks or the social distance required would be an input. So you would tell, you would indicate in the script what are the parameters that you want to change. You would also include output nodes, and these are your design goals. So the things that you want to achieve with your design, like perhaps the position or the orientation of the desks in the workspace layout. And then when you export to Revit, you get like a little bit of a review of the case study that comes up. So it tells you like the logic that the script is following, and it validates that logic. It tells you if it's not validated, it will tell you, hey, there's something wrong or whatever. And then the logic that is used to define the script is given in a definition. And so this is that anyone who uses the script knows what the script is trying to do. So this one, for example, generates rows of disks with partitions in a room. It also takes account of any doors or windows or columns that might be on the floor, and then would place the rows of disks accordingly, and then also calculate the distance from the disks to the exit and also to the views outside. You can also upload an image for reference to see what it is that you're working with. And then it also tells you where the file will be saved. You can elect to keep or clear the test data. And then when you are happy, export to Revit, and then use it in the generative design studies. Okay, so we'll also do, Wanin will show us a little bit more about this in action. But before I hand over to her, I also just want to talk through some other practical examples in industry. So in one type of scenario, you might want to maximize functionality. So the next script that I'm going to show, it's just highlighting 3 different examples. The first one being stadium design. So as the designer, you want to maximize the number of seats in the stadium, but you also want to make sure that each person has got an adequate line of sight to what's happening inside the stadium. The next one would be a parking layout, so number of parking bays versus the reticulation of the cars in the parking space. And then the last one is shows how a hospital layout can be optimized by placing the position of the nurse's desk in a room such that the nurse is able to travel to the various patients in a short period of time. Okay, so here you have a bunch of people that's going to watch a baseball game, and they all want to have the correct amount of sight. So this is a typical calculation that would be used. So as you can see, it's a very simple calculation, but you would have to do it many times so that you can maximize the number of people in the space and also make sure that they all have at least some kind of minimal acceptable kind of view. So using generative design, you can produce many options. The same for a parking layout. You can do like a little bit of a test. You want to optimize the number of bays, but also make sure that everybody can comfortably get into their bay. And then this is the hospital example where you've got a bunch of patients in rooms around the building. So you want to see where to place the nurse's desk and how long it would take her to travel to each patient's room. So generative design can automate something like this very easily and give you feedback very quickly as well. So these examples are cases where you would want to maximize the functionality, and this is often used in your concept design. So you can make good decisions very early on, because when you make bad decisions from the beginning, that sometimes snowballs into a lot of wasted time and sometimes wasted effort. So another type of scenario would be to minimize waste. So let's say, for example, you had this desk and you wanted to tile it, but you want to select a tile that size and shape would fit this geometry good enough so that there is not that much cutoffs, like the tile cutoffs. So using a generative design software can help you to determine the size and the shape of the tile to use to suit the given geometry. Okay. So now I'm going to hand back over to Anin, and she's going to talk to us about using the software.
Okay, so if we want to look at how do you create a typical study within Revit, I just want to quickly skip this slide. Naran is the control back to me. I just want to make sure.
Okay, there we go.
Okay, let's just see. Okay, there we go. So as we've just seen, we've got this generative design tools that we have allows us to do many great things in design, from simple desk layout planning to more complex things like your stadium designs. Now, if we look at where we are currently in 2021 in terms of design and also industry, COVID-19 is unfortunately a dominant factor. So for this example, we will thus be showing you how to create a study with generative design to do workspace layout for health guidelines, and in this instance, COVID-19. Okay, so as more people return to the workplace, your design decisions takes on new significance. From the safe arrangements of desks and the width and spacing of aisles, up until the density of your seating. And we know by now that better data informs better decision making. So by using Dynamo and also Revit, you are able to combine art and science to do various design explorations with the intent of making more informed design decisions. So if we wanted to just quickly look at a typical workflow of the basic steps of how you set up a study like this in Revit, it would look something like this. So your starting point would obviously be to make sure you've got the tools that you need. Your Revit model has to be set up and established. And once that is done, within your Revit's Manage tab, you will select Create Study. From there, you will select the type of study that you want to do. And then you will select the method or the algorithm that you want to use when generating your outcomes. Then you will select your model elements to use if you want. Also, you will set your goals and constraints. You will choose your variables. You will then start your study, and you will evaluate your outcomes. And once you find a suitable design or layout that you like, you use that, and you can do further design development on that. Okay, so in the next video, we are going to look at how do you create a generative design study, and this is now for a workspace layout. Just get it started quickly. Okay, sorry, I'm just going to go one back. Okay, so the challenge of repopulating offices with COVID-19 is obviously the need to maintain a safe physical distance between people. And generative design can be used to quickly generate various design alternatives. So your goal is to ensure that your employees maintain a minimum safe distance from each other. So in terms of your constraints, you need to fit in 32 people with back-to-back desks, and also you, as an extra measure, you can incorporate glass panels, and ideally in this open office you want both of your partitions to be functional. Okay, so you then start your study. In this case, you choose your workspace layout and you start defining your parameters. So for this option, you can then see that you are able to actually fit in 40 people in desk clusters of 4. You group them together, also with glass panels in between, and then the rotation is at an angle in the open office. So it can perhaps work, but it's not ideal, as you will see just now, one of your partitions, the red one, gets obstructed. Okay, so you then head over to a second option, your grid object placement, to try out another option. So with this, you start grouping your desks in clusters of 4, and you also see then that you're able to fit in 56 employees, but your rotation is different. It's along the length of the room. But yeah, once again, your partition is obstructed and it's not really the ideal. So as a third option, you can maybe go for the same orientation that is now perpendicular to the window, but you start grouping them in groups of 3 desks. And you also remove the back-to-back placement. And this is actually, you're getting somewhere your partitions works. But maybe as the last option, you want to have more space between your desks. So you can maybe opt for the step grid object placement option. And sorry, Naran, I just that's not a problem, but I think that was in any case the last bit of the video. But from this whole process, you can actually see that you can derive that an optimal layout without manually having to move a single desk. So you can imagine if you had to do all of this design iterations, how long it would have taken you. So this is really the value of generative design, and also, yeah, it's not as complicated as it sounds. With that, I will hand over back to Naran if she's ready, just to take us through using the software in Dynamo. Naran, if you can just unmute yourself.
I'm so sorry about that. I clicked something by accident. But is the screen back up again? Can you see the workspace layout again?
Yes, it's fine.
Okay. Okay, so thanks for that, Anine. I think it gave a nice overview of making use of the generative design tools in action, and you can see how the model responds to whatever option you select in the case study. So similarly, I'm going to show another example, but this one is for the positioning of a crane. This little clip is just going to give an overview of a Dynamo script that was created by an Autodesk technical consultant, and it was specifically designed for a precast building that requires trucks to enter a site on a given route, and then these trucks will have the precast concrete panels on them, and they will be lifted by the cranes that you see on the picture, and then placed into position in the building where they need to be. So a contractor would typically need to order these cranes and then also position them in the best location where they can both reach the back of the truck to pick up the concrete panels, and then also place it in the correct location of the building. And the crane has some constraints as well, such as how far it can actually reach, and then also the weight that it can lift. So this script that you're going to see in action considers all of these constraints, and the color codes that you see on the building that basically is showing what the results are. So the goals that were defined in the script were there were basically two. One was that the panels should be light enough for the crane to be able to lift it, so within the crane's weight limit. And then the second one is that the crane obviously should be able to reach it because the crane has a specific arm length. So the green parts meet both criteria, so they both are light enough to be lifted by the crane, and they also are close enough that the crane can reach it. The parts in red, they might be light enough, but they can't be reached by the crane. And the parts that you see in orange, they can be reached by the crane. You can see it's within the crane's limit, but it's not light enough for the crane to lift it. So I'm just going to go ahead and play this, and you can see what happens. So this is now being exported into Revit, and a case study is created. You can see the various inputs and outputs. You can also specify how many solutions you want to see. Obviously, the more solutions you select, the longer it will take. But when I say longer, I mean minutes. And then you can view the various results. So you can see at the bottom there are various options, and it also color codes what can be lifted and what can't. You can also filter the results by looking at the graph. So in this case, you're looking at the lift score. So you want to have the option where there is like the lightest or the easiest for the crane to lift. So that's the option that was selected in the case study, and in Dynamo you can see that a much larger part of the building is now green, meaning that both requirements have been fulfilled. The panels are light enough for the crane to lift, and they also are reachable. You can see some orange and yellow bits, so that would have to be reviewed, and you can go back to your case study, you can refine it a bit, and try to find an option where everything is green. In the event that there is no situation like that, that means that the contractor will have to relook at the crane and have a crane that is either longer or a crane that is able to lift more heavy objects. Okay, so that's basically it from us today. I hope that it was interesting and enticing enough, but before we leave, we just want to run through some takeaways from today. And yes, would you like to talk about the problem solve?
Yes. So just to recap quickly, problems that it solves, it saves time on simple tasks. It cuts down on iterative design processing by automating your workflows. Like I showed in my example, you don't have to do all the manual work. Also maximizing on your functionality, minimizing waste, which is also a great benefit, especially during construction, and then also more accurate and informed decisions by having better data. Okay,
then just from me for some tips and tricks or for best practices when you do decide to make use of these tools is that there are some nice out-of-the-box case studies that are available. So as a starting point, it would be nice to play around with those. Everything is there. You really just have to click on some drop boxes and type in a few things, but it will give you an opportunity to see how Dynamo and Revit respond to each other. And then, you know, once you get into it, a good place to start is to make use of the open scripts that are available. There's lots out there. All you have to do is do like a Google search. And when you get to the point where you are customizing your scripts or making your own, I think some advice I would give is to make your scripts as generic as possible. And that is so that you can reuse it on multiple projects. So you want to make sure that the time that you invest into designing your scripts will be reusable and scalable for the future of the designs that you will do basically for the rest of your career. And then just final before we close off, we would just like to have like a little bit of a poll to get a feel from the audience. So if any one of the organizers can launch the poll.
Yeah, I also tried from my side. Maybe Shuaib, are you able to help us with that?
Perhaps Richard.
There we go.
Okay, cool.
Yeah, so if we just want to get a feeling of from your guys' side, how familiar are you with Baker Baines and the services we provide? So maybe if you can just choose an option that's most relevant to you. Yeah, we might just give it a couple of minutes to just check what feedback we get.
Thank you, Anin. Thank you, ladies. I think that, gosh, I mean, it's so fantastic to see the relevance of this technology, especially with what we're all facing from a COVID perspective in terms of figuring out how many people you can fit in an office and those kinds of things. I'm going to close this poll now. I think we've collected all of the responses. I'm now going to post the second poll, which is specific to generative design, asking, would you consider generative design in your current workflow? Does this solve problems that you didn't even know you had? I think for me, just seeing the relevance is incredible. And then I suppose also from a sporting perspective, you think to yourself, wow, someone really had to think quite carefully to make sure that you can see the field. Of course, you know, sporting events might be a distant memory for the current time frame. It's very interesting to see, I'll just share this with you, that of the respondents, that it looks like roughly 25% of you on the call have already incorporated some sort of generative design workflow, which is fantastic. I mean, that just shows that you're really on top of things and that you're very innovative and leading from a best practices perspective. I see that the responses have dropped off now, so I'm going to close the poll, and I'm going to ask Shuaib if you can take over being the presenter, and I will introduce you. So for those of you who have been with who've known Baker Baines for quite some time, you should all have seen and heard of Shuaib. The different iterations of his name, gosh, if I had a rand every time I had to try and help someone pronounce his name better, I don't think I'd need to work. Shuaib, if you could put your camera on, if you could, are you the presenter now?
Yes, I am. I'm just getting my screen up and running here.
Fantastic. And then put your camera on so that everyone can see what you look like. While Shuaib is busy getting his slides up, a couple of things that you might want to know about Shuaib. Last year, Shuaib qualified as, Shuaib, help me get this right. I don't want to muck it up. If I'm not mistaken, it's a civil technologist, is that right?
That is correct.
Thank you for that. And then something else that you might not know about Shoaib is he's quite an avid surfer. When that's allowed from a governmental perspective. I always laugh when I'm driving into the office. I hear the 5FM weather report and they always talk about grab your stick and call in sick. Thankfully, Shoaib doesn't do that. But Scan to BIM is what Shoaib's going to take us through today. Shoaib has got quite a lot of experience in this particular part of workflow. He presented something fairly similar at Autodesk University last year. And this is a very exciting workflow that I think will change how a lot of you work moving forward. So Shoaib, over to you.
Thank you very much, Richard, for that intro, and welcome everyone for today's session on Scan to BIM 101. So the reason why we've titled it that way, I'm going to show you some tips that you could actually incorporate to reap the benefits of this actual Scan to BIM workflow. So if you are new to the Scan to BIM environment, I'm going to give you a brief description on what it is, and then we're going to jump in and look at how it is generally done in industry. So how are users actually executing this task currently, and how can Scan to BIM actually make it better, and what problems does it solve? Yes, it does have some limitations which a lot of people aren't aware of. And then, of course, I'm going to give you some tips to get it up and running and make it work for you. All right, so Scan to BIM, what is it exactly? So as you can see on your screen, on the right-hand side is actually our Baker Benz office that I did a scan of. And on the top here is actually the point cloud. So if you haven't seen a point cloud before, that's more or less how it looks. And at the bottom is the Revit model that has been generated from that as-built captured data. So Scan to BIM involves the integration and application of 3D scanning technology and BIM application and processes. So it's a hardware that's using laser technology to actually capture your reality and bringing in that to a BIM intelligent environment and modeling of it. So it results, of course, in reality capture. So that's where the name comes from. And it makes modeling much more easier. So think of it like this. If you were tasked with going and measuring up a building, it's quite a tedious task. I have been there in the construction industry, and sometimes you always kind of forget something, a certain measurement, a certain dimension. And with laser technology, whatever you see in your reality, it's actually captured in an automated process. So scanning or reality capture can be carried out by a variety of methods. The most popular one is using a 3D laser scanner. So the one that actually sits on a tripod. You've got a handheld, which is recent, really cool. An example of it is the BLK2Go. It literally fits into your hand and you literally walk around and scan the building. And of course, you've got the one that's popular in, I would say, infrastructure and mining, using drones and UAVs. So there's a lot of different applications of Scan to BIM. And once the data has been verified, so the data that you have captured using the hardware, you can bring it into your design interface. You can use it for design, analysis, as well as visualization. So when it comes to the as-built part of it, how is it generally done in industry? So I like pictures. So I'm going to show you currently what I've seen the users do in industry. So first of all, we normally go and get some measurements of the existing site, and unfortunately, this is via tape measure, right? It's a pain, to put it quite blunt. And then we try and sketch this onto our actual environment by hand. Once we've got that, it goes to construction. Once the construction is complete, we have to go and then re-measure what we've built, i.e. as-built capture. And this will then need to be traced, right? So you will take that same dimensions, trace it. And I think the most difficult part of this is actually overlaying it onto the original blueprint. It is really, really complicated and very tedious. So the key element in these phases, first of all, it's manual measurement and design. Construction is complete. It's manual again, because you literally have to go and measure everything. You have to sketch it manually. And of course, overlaying and stuff like that is also manual. So the key word in this is actual manual. Of course, along the way, AutoCAD came into place. It helped us digitize this a little bit. So it took us off the drawing board and put us onto a digital environment, and we could actually draw much more better. But it's definitely not the tool now that's actually catered for the built environment. There's much more better technologies that are available, but the traditional workflow, it's still very cumbersome. So if we're going onto the construction side, this is something you would always see, right? And it is very painful, it's manual, and is also inaccurate. So if you're looking at the infographics at the bottom, first of all, you get the blueprints or you get the hard copies on site. You would need to go and trace and align the as-built nature of the building versus your original design intent. You will need to go and measure and mark up. Eyeball installed, I have seen this a lot in construction, where you would actually look at predominantly at the ceiling. That's why the image has that. And you would say, hey, this actually needs to go somewhere along there. It's not very accurate. And of course, this affects your operations and maintenance down the line. So drafting changes for this is also really, really difficult. Of course, throughout the world, most of our infrastructure is aged, with 80% of buildings falling into that category. And of course, we don't have the as-built for it, or there were some hard copies that have went missing. I've encountered this in many of my design processes where there's no data available, especially for operations and maintenance, upgrades, refurbishments. It's really, really tough to pinpoint everything. And that data is critical in the longevity of the actual building. And last but not least, if you're a property developer or if you're a design consultant or you fall in the category of the AEC industry, these three words should not be strange or foreign to you, which is production, demand, and product, right? So if you get it wrong from the start, or if your asset is going down a domino effect of negative influence, it's going to really affect the design life of your building. And this is where unreliable project costing, variation orders, forecasting, all of that just really goes haywire. And this is a critical and very big problem that we've seen in civil infrastructure. So how does that relate to the benefits or the scan to BIM workflow? What type of problems does it actually solve? So let's have a look. So first of all, when it comes to the capturing part, so reality capture or as-built capture, measurement obtaining, we use automated technology and hardware. So you can see there's some laser scanners there. We've got the TopCon, which is on the civil infrastructure, mining, construction side part. You've got the Leica BLK, that is a tripod type of scanner where it sits on and it's used for interiors. And then if you haven't seen a handheld, that's literally how it looks. It's really, really small. It fits in your hand and you can actually walk around. And if you want to go something really more trendy and a hot topic in civil infrastructure, you would go something like drones. Right, so once we've captured the existing environments, you would need a type of BIM application or point cloud specific application to process and verify this data. And that's what you would need to use. Once you go there, you would use your application of choice, your CAD platform, get your design model, and then of course, you would use the automation technology to actually repeat this process and capture the as-built environment. So it's fairly more automated. Now, at Autodesk University last year, I've actually presented a more refined approach to actually further automate it. So what we're looking at here is actually scanning, processing, modeling, and of course your as-built. Now, the workflow that I've actually proposed is called the refined scan to BIM workflow, where I've incorporated actually visualization elements as well as further automation. So what I mean by that is, yes, the first step will be exactly the same. It'll go then to the processing, but this is the game changer part of the actual scan to BIM workflow that a lot of people actually became aware of after the presentation. But if you haven't heard of it, there are point cloud geometry extraction technologies. It's a bit of a mouthful, but what it does is it identifies the linear objects like walls and stuff like that in your building, and it extracts the geometry for you. So it saves you like 70 to 75% in the modeling phase, which is amazing. And once you do that, you could actually incorporate that into Revit, which is the flagship software used in the built environment. And it comes in as Revit Intelligent Family. So you don't really have CAD, 3D, or 2D elements that have no intelligence attached to it. You could actually define the metadata and get it to a much more higher level of a great asset model. It's the basis of a digital twin. So once you do that, we will get it constructed, of course, construction is complete, and then we can really refine or reuse these steps to actually get to the as-built data, which is much more quicker and streamlined. So scan, process, extract, model and visualize. I actually linked this to stereo panoramic virtual reality. So if you have a headset, you could put it in your phone into a headset, or you could use your phone just as it is and literally look around your model before it goes to construction. That is amazing when it comes to verification of design. And then of course you will get constructed and we can wrap it up with the as-built capturing and modeling. Now, coming down to the problems, what does it actually solve? So first of all, you have a level of accuracy that's automated and is critical for the basis of your design. Good data equals good design. You've heard this said previously, as Anine has said prior to me. Good data is good design. And by something that's automated and depending on the hardware that you're using, you can get up to millimeter accuracy, and it just makes things much more streamlined. Of course, manual intervention is reduced, which we are all a fan of. I don't think anyone likes to go and tape measure a 15-story building. Good luck with that. When you get the basis right, you're going to reduce issues and change orders. So the variation orders, your revision to your scope of works, all of those things really are negated. And then, of course, you're going to quickly capture existing conditions in high resolution. What I mean by this is whatever's around, first of all, you're not going to miss it. So you don't have to go back. If you miss certain dimensions, if your site is like 4 hours away, which is normally in the mining space when I go, you don't want to do that. And the great thing with this is the scan has an image burnt onto it. So you don't have to worry about taking photos of the environment. You could actually switch to a photorealistic view, and the actual point cloud would has the geometry attached to it. Fewer physical site visits, that's exactly what I said. Decreased project costs, of course, great leaner project management, reduced rework, and of course, modeling becomes a bit more easier compared to using sketched dimensions, which sometimes, if you have handwriting like I do, is quite difficult to read what the person has actually jotted down. And if you want to take away this in a picture, this is literally what we are solving. So you can see the green element is the actual final design model that went to construction. And what happens is sometimes, especially with piping, ducting, you might have to skew it a little bit. And the point cloud reflects the actual designed or constructed element. So you could actually revise your design, get your as-builts out there, and it makes for much more informed operations and maintenance. So it all boils down to, so the scan to BIM workflow is going to give you these competitive edges. First of all, it's going to make you better at what you do. It's going to make you faster. It's going to make you more leaner and innovative. And of course, it's going to keep you up to standard. So it's going to make you more newer. So now that you understand what it is, what problems does it solve, what are the limitations to something that's so good? So there are a few, some of them might be quite obvious, but it's nice to just put them out there. So first of all, weather. Please do not go and scan if there's an avalanche or a hailstorm or it's raining. That's on you. You're not going to get really good data on that part of things. So if you're doing outdoor scans, it should be really good weather, nicely lit depending on what you're trying to scan. So a nice sunny day, you could do it on an overcast day depending. But yeah, just bear that in mind, right? The area to be scanned should be vacant. So what I mean by this is, let's say you're scanning a building and you're doing maybe the second floor of that. Try and get the people out of there or any moving elements. The reason being is you would see a disturbance in the scan where you would see sometimes floating people. It's not that your scanning result is haunted or you picked up something supernatural. It's actually because movement actually plays a big role in the actual scanning environment. This one I've heard quite a bit, which is large data sets requiring sufficient storage space. Yes, depending on the size of your building, your data sets can get quite large. It's not a problem though, because the software can handle it, but you do need a decent computer with sufficient storage, or you could get a external hard drive or something like that, just to ensure that you've got enough space for your scans to be processed and stored. Equipment can be expensive. However, what we've seen is if you do a business process analysis, which we have done many throughout the years, it actually aids in long-term saving, and sometimes actually short-term. The savings are great. So it might be a bit upfront costs, that's a bit much. However, if you compare to your business model as a whole, it's actually a really great saving. Of course, you can hire the equipment as well. So we also offer that. But if you do go and actually purchase your own machine, you will see the benefits of the saving and, of course, the level of detail that you're using. It's also very important to ensure that you get the right scanner for the right applications. So, for example, you would not use a scanner like, for example, the BLK 360 that's predominantly used for interiors to scan the plant. You would need something that's much more of a finer accuracy, millimeter or micrometer if you do get them, and it's catered to capturing plant at the level of detail that you need. So you need to bear that in mind. Other limitations, I would say manual registration can take long, but I will get back to this when I'm giving you the tips to avoid this. Point out data, same thing. It can be a bit overwhelming if you're new to this space. The main iteration here is point cloud does not equal a CAD model. So you would get a point cloud, of course. It will give you the building. You will literally see it. You'll see the color of the paint. You'll see the columns. You'll see all of the associated furniture, but it will not give you the CAD model. It will give you a representation of the reality. You would still need to model it off. And that's why I'm such a big fan of cloud extraction geometry. So if you can incorporate that, it'll help you save a lot of time. But I'm going to give you a tip now to actually help you with the modeling. So this brings me to probably the final segment of my session on the Scan to BIM 101 is, what are the best practices to actually help you reap the benefits of the Scan to BIM? So first of all, your checklist. I am a big avid believer in this, understanding over applications, right? Whether you're doing a design class, whether you're doing scanning, it's the same thing with anything in life. You need to understand what you're doing first before you could actually execute it. And when it comes to scanning, you need to understand what exactly you want to achieve by it. What is your objective? The area that you need to scan, how big it is, the accuracy, those type of things. You would need to think of them beforehand, get a grip on them, and then it'll actually make your vision forward much more clearer. Also, I've reiterated this, correct scanner for the correct application, as well as the software. So if you're doing buildings, you would need a certain scanner. If you're doing plant and so on, if you're in a construction site, you would need a different type of scanner. Setup points should not be spaced far apart. So how you would actually capture a building is you would take the scanner and place it at critical positions to capture your reality. But sometimes what I've seen from users is they put it too far apart. Now, when it comes to the accuracy, an overlap is really, really critical. So if they are too far apart, that overlap kind of gets misconstrued. It could lead to manual registration, which is something you really want to avoid as the best as you can. But if you do it in the correct manner, you wouldn't even need to look at manual registration. Angles and line of sight are crucial. So good scan equals good data, and it makes it easier for the modeler, right? So your BIM modeler will have an easier time if your scan is done in the correct methodology. So you need to understand where to position the scanner, what you're seeing, what you would presume that the modeler will be able to see in Revit. All of those things are very critical in the methodology of getting really good data. Vacant area equals no interference. I've said this, that if you have a vacant area, it's really good. I mean, you could actually get some really good crisp data with no interference. This is a critical one to the modelers. So if you are the person that's receiving the point cloud, my best tip is to actually segment the point cloud into regions for modeling. So let's say you're doing a big floor plan and you're just starting on the northeast corner of the building. You don't really need to see that entire point cloud. What you can do is region it, or if I could use a simpler word, crop it, right? So you only see that region visible. So you could actually do the modeling bit by bit. So just keep that in mind next time when you're actually in the modeling phase. when you're looking for something that's really precise, you need to incorporate targets. And of course, like I said, cloud extraction technologies if possible. If you're not aware of what targets are predefined survey points that are taken off a building before you could actually do the scan. So it has an X, Y, and Z coordinate attached to it. We normally use like a checkered board against the wall. That is a mapped out point. So when you do process your data and you upload those coordinate points that have been accurately derived by a surveyor, that will actually tighten up the accuracy and the angle of your scan. So it's a really good process to use. I also use it quite a bit. Even if you're doing drone scanning, control points, ground control points, it works on the same methodology. Right, and I think that is it for me. I will actually hand you over back to Richard right now, and he can actually take it away. So Richard, I will just hand it over to you.
Thank you very much, Shoaib. All right, everybody, I know I'm very conscious of the fact that we've gone over time. For those of you who do have questions, please feel free to pop them in the chat box. I'm probably going to give you about 3 or 4 minutes for your questions. And then I think we're just going to bring it to a close, primarily just because, you know, from a timing perspective, I know that there was a lot of exciting content shown today, but, you know, we want to be mindful of your time. So there is a question, would Dynamo and Revit also work for mechanical projects? If I may just respond to that, the asker, Nobuhle, and when you say mechanical projects, are you talking about things like HVAC and plumbing, or what kind of mechanical projects were in your mind? While you're maybe thinking about that, in the meantime, let me ask which one of our panelists are going to take that one? Anin?
Yes, I think definitely. No, I will take it. You will definitely able to do that. So I know that we focused a lot on the architecture and also the structural engineering side of things, but definitely you will be able to use that for mechanical projects as well. If we have more detail, we can maybe give you better feedback on if we understand your question a bit better.
Thanks. Thank you, Anin. The short answer, Nobuhle, is yes, it can, but maybe a bit of a touch base with you would be useful. Are there any other questions? Thank you, Ramon, for your statement. Okay, so I'm not seeing anyone typing anything. I think what I'm going to do is I'm just going to move on from a Baker Baines perspective. If you do have any questions that you want to post, feel free to post them in the meantime. From our perspective, it's about when we help you, how do we help you? And for us, we focus that around our iAdopt consulting methodology. Specifically, that's about understanding the purpose of what you want to achieve first, and then moving through the processes of assessment, education, and consulting. And we're very passionate about this particular methodology because technology is just an enabler. And you know, if you don't train the people and have the right workflows in place to solve those problems, it's really going to be a waste of money and you're not going to get the return on investment, which isn't good for anybody. So really, in the interest of time, I'm just going to move forward on this. Really, in wrapping up of today, I think it's important to remember that we need all to have a single source of truth to be able to enable better collaboration on projects. This is achieved using the Autodesk construction solutions. Further to that, it's about improving design efficiency. I think that the things that were presented today were incredibly exciting, but there's also a lot more that we could work with you on in terms of business process assessments, better training, generative design Kickstarter program, which is actually very exciting. So for those of you who haven't implemented generative design, you can reach out to us about our Kickstarter program for that. And then lastly, it's about capturing existing building conditions, and we have an array of services to help you there, whether it's from renting the Leica BLK or from renting the Leica along with someone like Shoaib to help you. But there is also a Kickstarter program in place to help you learn how to do it. Our philosophy at Baker Baines has always been, we rather want to teach you how to fish so that you can fish for yourself. In terms of how to connect with us and how to make things happen, please feel free to reach out either to Jackie, who's the head of BIM technology, and she's based specifically in the Western Cape. But nowadays with COVID, as Julia Roberts said, that's just geography. So Jackie's able to engage with customers countrywide, and Yanni, our director of professional services, who is very familiar with most of you, but also I ask you to go and find our presenters on LinkedIn and connect with them. They're always sharing some interesting and insightful pieces of information. And really from our side, that's that. We hope that you follow us on social, that you stay home, that you stay safe, and looking by today's weather, that you stay off the roads. Thanks very much, everybody. Have a great day.
Bye.